Alright, hey everybody. In this next part of our tutorial series on creating a first-person narrative game, I'm going to cover creating interactive objects and just a framework for our player character to interact with the world. So to get started, let's review how we've sort of defined this feature in our game design doc. This is our sort of sample game that we're creating in this demo. And let me just skip to the section about interactive objects because that's what we're going to do today. So I just sort of typed this up before I started the feature because I want you guys to kind of get in the habit of doing some light documentation to sort of define what you're making. And we can use this as a guide moving forward as we step through the process. So interactive objects are just things that the player can look at and click. And when they click it, it should react in some way. And that way it can be different based on the object in question. So it says examples include activating a switch, playing a sound, opening a door, etc. It says the player can interact with objects in the world by walking near the object, looking at it, and so that means just pointing the camera at it, and then pressing the interact button. And I'm going to make the interact button left click. So this is what we're going to start with. And I guess we can we'll check out the rest of this when we get to it. So we'll just start with these three things. Okay, so I'm going to flip over to Unity here. And this, I think, is pretty much where we left off, actually. I may have gotten a little further in the last video because I used to have a floor and a player. So really quickly, let's go ahead and set that up. I'm going to hit Control-Shift-K in Pro Builder. That's the hotkey to get the shape tool out, and I'll just make a plane. And this is a 10 by 10 plane. That should be plenty for just prototyping this interactivity feature. So I'll just go ahead and choose build, and there's my plane. And now I need to get a player in here, and for now we're just going to keep using the standard assets, first person, rigid body first person character controller. Actually you want to go into the prefabs, and this is the one we want to use. So I'll just drag that in. Got to make sure we put it up over the floor, and it's okay if it's a little above because gravity will just kick in and you'll fall right down to the floor. Let's just really quickly run the game and make sure that I can walk around and look around just like I would expect, and it appears that I can. You can see the directional light is really kind of creating a glare on the floor, so you could adjust the angle of your light if you want it, if that was bugging you. But since I'm really not doing a lot of level design in this example, I'm just going to live with it. Alright, cool. So this will be my basic test level. I guess one more thing I should probably add here is just some sort of object the player can interact with it, like a placeholder for an interactive object. So I guess I'll just quickly add, I'll just add a Unity cube for this. So 3D object cube. Unity cube is a little different than a Pro Builder cube. Basically, you just can't model with it, but it will serve as a thing I can walk up to and look at and click on. So that's what I will put in my level for now. Okay, so the first thing we need to do is give the player a way to detect when they're looking at the cube or any interactive thing. And there's a lot of ways we could do this, but I think one of the simplest or most straightforward and decent to learn examples is going to involve raycasting. And I would say this is maybe an imperfect solution, but it's going to be more than enough to get us off the ground. And then if there are shortcomings to this solution, we can think about how to engineer a better solution once we get going. But for me, I just want to get a quick, usable, playable prototype happening so that we can test our game and start building the game more before we get too locked into making a super robust feature. So, if you want to learn more about raycasting, say you've never done it, I'll put the notes for this presentation in the video description, and on the last couple slides here you should see a series of links. This one in particular is a Unity tutorial about raycasting. So if you've never heard of raycasting, check it out. But for me right now, I'm going to look up the Unity documentation for it because it's going to help us write our first function here. So I'm just going to search physics.raycast Unity. That should be enough. There's the first search result. And so here's the documentation for raycast. You can see it says it casts a ray from point origin in the direction of length max distance against all colliders in a scene. So what it really does is it projects an imaginary line from a point in space in a direction of your choice. So in our case, the imaginary line we want to come from the center of the camera out forward. So we can work on visualizing that, but I think the first step here is going to be to just make our script for this. So in your assets directory here, go ahead and right click, create a new folder, and let's call it scripts. We want to make sure we stay in the habit of making folders for each category of asset in our game. Inside of the scripts folder, go ahead, right click, and create a new C# script. Now, I could call this script like player character, right? And inside of this player character script, I could put all the stuff that would ever have to do with my character. Moving, jumping, looking at interactive objects, interacting with interactive objects, dying, whatever the player could ever possibly do, I could put it all inside of this one monolithic player character class. And that would work, but the larger my game gets, the sort of more difficult and unwieldy that class would become to use. Plus, it invites what we might call coupling, wherein different features are more intertwined than they actually need to be, which makes changing one of them more complicated without introducing bugs, basically. So rather than, sort of the opposite of coupling is something we could call separation of concern. So this is actually a thing I don't have on the notes, but I guess I'll go ahead and add it now. And this just says, it's the idea that we want to separate our program into distinct sections to make it easier to use and less likely to be buggy. So this way, let's say you're a programmer and your job is to implement or fix a bug in the jump code. Well, if everything that has to do with the character is all lumped into this huge player character class, it may be difficult to fix that bug without understanding everything going on in that class. However, if we chop things up and let's say we just had a class called jump, then you would know right away, all you have to do is open up that jump. You can safely do whatever you need to do within the jump class. You don't have to worry about understanding every single thing the player can possibly do in order to fix this bug in jump. So that's an idea, that is involved in an idea called the component pattern as well. So I just want to put this on here too. And you can see it says the intent of the component pattern is to allow a single entity to span multiple domains without coupling the domains to each other. And so this is really inherent in Unity. So when you go to add things to a game object, there's a whole add component button here. So rather than having this giant class that describes the object's position, the way it behaves as a physics object, its collider, how it moves, how it looks, all these things are broken up into separate components. And so not only does that help separate concerns, but it also makes things a little more reusable. Like I can reuse this capsule collider component on anything that needs collision. So it makes our code more modular, as well as being easier to sort through and use. Anyway, long story short, rather than make this giant player character class, I'm going to make a very specific component that describes exactly what I want this class to do. So go ahead and delete that player character class if you've already made it. And instead, we're going to create a C# script in here called detect looked at interactive. And basically it's going to search for interactive objects. So you can see it's named very specifically. Let's go ahead and open that up in our script editor here. Alright, so here is our code, and what we want to do first is get started with that raycast. So maybe I'll just go ahead and paste a link to the documentation right in this class so we can reference it quickly. So I'll just put this at the top. Here's another thing I want us to get in the habit of doing. When you make a new class, up above it, right outside the name of the class here, if you tag / 3 times in Visual Studio at least, like that, we get this thing called a summary tag. And I want us to get in the habit of basically explaining what the point of this class is before we really start making it, because it'll help us stay true to what our intent actually is, and not get sidetracked by just development for the sake of development, which sounds crazy, but trust me, it happens. So let's see, how would we describe what this class is? I think I'll just say that it detects interactive elements the player is looking at. Alright, and then just as a note, I'm going to paste in this raycast link, even though, eventually we can get rid of it if we want. But this is just for me to use and reference as I work forward, because this is going to be the first thing we need to do. So, again, let's visit this. And what I like to get in the habit of doing, or what I find useful, I guess, you can see the parameters that the raycast function needs. So if you look at the example there, they call physics.raycast, and they're passing in all of these parameters, right? So there's a parameter for the starting point of the raycast, what direction it goes, so on and so forth. I think we should make variables for these parameters that we're going to use, and then that will just help us sort of keep our raycast straight in our head, and it'll make it really easy to call the function once we have all this stuff already figured out and decided on individually. So let's go ahead and make some of these. I think make sense as serialized fields. We're just going to delete start and update for now, and they'll probably come back, but they're just kind of in my way for the time being. So first off, let's make a serialized field. So this will be a private transform, and it's going to be for the origin of our raycast. So let's see what we should maybe call that. How about just raycast origin? Pretty straightforward, right? I'm really throwing a lot at you guys right off the bat here, and that's kind of going to be how it goes, I guess. But another new thing I want us to get in the habit of doing, so we talked about adding summaries to our classes right when we make them. Whenever we make a serialized field, remember a serialized field is going to be exposed to the Unity editor so that the designer can plug something into this slot. Well, we need to make sure that the designer understands what it's for. So the first step in that is giving it a really good name, which I think I've done. It's pretty clear. But if we wanted to go even further, we can add what's called a tooltip to this. A tooltip attribute. And this is just a thing in Unity. Let's see, it's probably in the notes too. Let's click that real quick. Tooltip attribute. So you can check this out and read all about it. But basically it just means if you mouse over a serialized field, it gives you a tooltip. Makes it very clear on what this value represents and what kind of number or data is supposed to be plugged in. So you use it, you just type tooltip inside of a square bracket, and then you have to open parentheses and pass in a string. So we'll just directly type in a string in quotes. That's going to be our tooltip. And we'll just say starting point of raycast used to detect interactives. Something like that. Again, maybe this seems like really just I'm being super redundant the way I'm naming everything and labeling all of my code, but it's a good habit to get in. Alright, so we've got the raycast origin. Let's go back to the documentation for raycast and see what the next one is. So the direction of the ray. So if we think about it, what direction really do we want? Well, let's just make the variable for it and we'll plug it in later, but let's go ahead and I'm not going to make this one a serialized field just yet. Let's just say private. So a direction, the type of data that's going to represent that is going to be a vector3. So vector3, we'll call it raycast direction. Alright, a vector3 just has an x, y, and z coordinate. It can represent a position, it can represent a direction, a few different things that vector3s are used for. But in this case, we're going to use it to figure out a direction. And the way that works is it just has what's called a magnitude of 1, which means it's like an arrow pointing in a direction that's only 1 unit long. So that's our raycast direction variable. And let's see, what's the next thing we need here? The max distance. So how far the ray should check for, it says collisions, but in our world that'll basically be interactive objects. So let's make a variable for that. Private vector3, or I'm sorry, this will just be a float because it's just in one direction, right? We just need to know how far to look, and that's just a regular old float. So let's call this something like max range, and we can give it like an initial value. We can say 5.0 f for float. And let's go ahead and make this one a serialized field also, because I can imagine the designer wanting to tweak this. So let's say serialized field. And let's give it a tooltip because that's the rules. So let's see, we can elaborate on this a little bit. Tooltip, it's going to be how far from the raycast origin we will search for interactive elements. And let's go ahead and fix our typo. Alright, so I didn't make this one a serialized field because I don't think it will be useful for us to try to initialize this in the editor or really change it often. So we'll just initialize this in like our start function or something like that. So we'll get to that. But these two are things I think, in this case, it's going to be easier to initialize in the editor. In this case, I think it's something the designer might want to tweak because maybe you want to be a little farther from the object and still detect it. Or maybe we want to make them get real close to it. We'll see how it goes. The only way to find out is to test, and so it needs to be easy to tweak. Alright, and then if I look back at the documentation, I can see there's actually a few more parameters, but I'm not sure that we're going to need to use those right away, so we'll just leave them out for now too, and if we end up needing them, we can go back and add variables for them. Okay, so to do a raycast, it's something, we got to figure out when we want to actually project this imaginary line in front of the player. And so if we just only did it once, like in start, that would only be helpful for like the very beginning of the game. So instead we want to do it repeatedly over and over, so that's update. But the raycast, you can see, even if you look at the documentation, it's physics.raycast. So most of the things that involve physics you want to do in fixed update. So let's go ahead and get our fixed update function implemented. And this is a Unity API function that gets called at a fixed interval as opposed to every frame. So regular update gets called every frame. It's as fast as your computer can do it. And so if you're doing something very expensive and as fast as your computer can do it, it'll have performance implications. In addition to maybe behaving in a way that doesn't feel consistent as the frame rate goes up and down. But fixed update gets called at it's still very fast, but it's a fixed interval, so it'll be frame rate independent and it will be less of a performance impact on our computer. So we're going to say physics.raycast, and once I open my parentheses here, you can see it says 1 of 16, so there's 16 overloads for this thing. So I can start hitting the arrow keys to go through and try and find one that works for me. This one, the number 7 version here, this looks kind of similar to what we might need because we have the spot for the origin, the direction, and the max distance. So let's start with this. So the origin of our raycast, we have a variable for it. It's just called raycast origin. So that's easy to plug these values in because we made clear variables for them. The direction is just going to be raycast direction. So we made a variable for that too. And the distance is going to be max. I call that max range just because I think that sounds more like related to this idea that the player's reaching out and touching an interactive object like a switch or whatever. So it just kind of fits the context of our design scenario more clearly. So that's why I called that one max range. Alright, so whatever, we can type that in and hit semicolon. So first of all, this one isn't working because this is of the type transform and it wants a vector 3. So remember in Unity, let's see, all of our game objects, right, they all have transform components. And one of the properties of a transform component is its position, and that's a vector 3. So we want to know the position of the transform. So I guess what we should say is raycast origin dot position. So this is our starting point of our array. Next question is, so we can type that in here, that's great, but it isn't, it's never been initialized. We have to fill this in or it doesn't understand what we actually want to use as the starting point. So now that our code compiles, go ahead and save it, Control S or the button. Go back to Unity and let's put this script that we started building on this game object that says rigid body FPS controller. So I'm going to go ahead and hit add component, and I'm going to type in the name of our script and click it. And assuming that you got your code to compile and you saved it, you should see some of these serialized fields that we made. So raycast origin, what do we want to use as the start point of this ray? We could just say, well, we want to use the player itself, but really it's more specific than that. we want to use like the player's head, the player's eyeballs, more or less. And the thing that's going to count as our player's head and eyeballs is this main camera. So the rigid body prefab, the rigid body FPS controller prefab, if you expand it, there's actually a main camera that comes in as part of this thing. You can see it there. And this is basically your player's head. So we want to use this as our raycast origin. This is where we're gonna. You can kind of see the, if you can see the capsule, that's our player's body. The camera is its head, and so we want to use this part of the camera as the point that we start our ray from. So where you see it say raycast origin here, just drag the main camera in, and it'll automatically grab the transform of the main camera there. So now, back in code, when we talk about the raycast origin, we know that it's actually corresponding with this main camera because we plugged it in the editor. So again, I made this one a serialized field just to make that easier. Easy to just visualize and drag it on in there. Okay, so the next one is the direction. And I said we wouldn't make this one a serialized field because this one's a little harder to plug in the editor. But there's still a neat way to figure it out. So how do we know what direction we want this invisible line to extend out in? And the way I like to visualize this is if you click on, our player's head, which is the main camera, right? We want that, we want to think of the ray coming like right out the front of his head. So if you select the camera, you want to make sure you're on the move tool. And once you're on the move tool, you'll see these little movement widgets. And these, right now, if you look up here, I'm in the global, I have the global setting turned on. And that means that these handles are aligned with the global axes. So this is global Y, so it's up, and that's global X, that's global Z. So when they're set to global, it's almost like north, south, east, west. These directions never change. But if we were to flip that to local, now it's going to show us the handles based on the individual object that we have selected's rotation. And I guess maybe the best way to visualize that, if I grab my scene window and I just sort of dock it in a way so I can see the scene window and the game window. We'll give this a shot here. So run the game and you'll see the gameplay. What we would normally see when we run our game is in the left window there, right? But pay attention to my scene window. You can kind of see the projection of the player's viewpoint. That's the thin white line. But look at the handles, the move tool handles. You see the blue one? That is, instead of being the world's Z coordinate like it used to be when this was on global, it's actually now the camera's forward vector. So, or it's whatever object you have selected. So if I were to select the cube, that's the cube's forward. So that's the direction that the cube is pointed in. This is the direction that my player is looking in, that blue arrow. So you can see it's not always the same. It's based on however that object is oriented. And if I were to flip back to global, you can see that it's always going to be the same. So the blue is always going to be that direction. So that's like, that would be like north or something. Whereas when we put it back to local, it's what direction are we facing. So this would be forward. So the game, Unity secretly knows what direction is forward for all of its game objects. It's one of the nice things that having a nice game engine to leverage is useful for. So what we can do is just automatically ask Unity, well, what's the forward direction of our raycast origin thing here? So I'm going to, let's maybe initialize that. Well, I'm going to actually go ahead and probably, I'm trying to decide if I should just delete this variable or we should assign it every frame. I guess we'll just go ahead and assign it every frame. So the raycast direction equals the raycast origin dot forward. So every vector 3 like this, or I mean every transform rather. So every game object in Unity has a transform. So every object knows about its, you can see its forward, you can see its left or its right. So if I wanted to know the left, you'd be like, how come there's no left? Well, left would just be right times -1. That's the opposite of left, right? Same thing with back. Back would be forward times -1. But anyway, we want to know the forward vector of our camera, so of our raycast origin here. So there we go. And so now all of a sudden this direction has a value plugged in right there. Since this is just pretty simple, it's not really saving us a lot of typing or space, I think I might just get rid of it and just plug it directly in here. So rather than having this variable, I'm just going to say raycast origin dot forward here, and then we can kind of get rid of a couple lines of code. So I don't think that's really helping it be more clear necessarily. Alright, so let's save this. Now the next part of our raycast function is the max range, how far. So we know which direction, we know where we're starting our ray, we know which direction it's going. Next question is how far. Well, we've actually already initialized this up here. We gave it a default. But if we were to go into the game editor here and select the game object that has that script on it, you can see there's that variable and we can tweak it. Well, it's going to be kind of hard for us to, it's hard to visualize still. Like I don't know when I'm playing it, so like in game mode here, like if you're just looking at this first person view, it's really tough to kind of understand how far 5 is. Like, is this going to be 5? Is this 5? And even if this is 5, is that too far? So I want a better way to kind of visualize it. And, you know, once we implement it, we can just try it. But there is a way to visualize a ray. So let's go ahead and go over that real quick. Oh, one more thing I want to show you. While you're running the game with the default first-person character controller, if you hit escape, you get your mouse back. If you click back in the game window, it hides again. So if you need your mouse, you can just hit escape. I should have mentioned that in the past. Alright. So anyhow, let's go back to our code. So this line of code right here, when we were running the game, it actually was doing the raycast. The raycast is just invisible, and we're not using it for anything, so it's hard to really tell that it was doing anything. So let's just write some debug code that makes it visible for us so we can see what it kind of looks like and visualize it. So there's a function called debug.drawRay. A line has like 2 endpoints. The ray is a start point and a direction. So anyway, draw ray. And frustratingly, it actually takes like sort of different parameters than the actual physics.raycast function. So we kind of have to manipulate our values a little to fit this. So the first part is the same. It needs to know the start point. So that's just going to be raycast origin.position, right? Second part is the direction. We know that too. So that's raycast origin.forward. And then the third part is the color. That's good. Let's just say we want that to be red. So you can C# or Unity, I guess, here has some built-in colors. So there's a color enumerator, color.red. There we go. We can just see it like that. And so You might think this would work, but if you read this carefully, it says it draws a line from start to start plus direction in world coordinates. So start plus direction would just be a 1 unit pointer in the direction we want it to point. But remember, we want it to actually use this, we want the line to be of the length max range. So all of these directions, like I said earlier, they're of one length. So since it's just like a direction of one length, I can multiply it times a float here, and all of a sudden I'll have a line that's this length in the same direction. So if that's all confusing, which I understand totally, I recommend to check out in the notes here. Unity has a vector math tutorial, and it may help clarify things a little bit. Otherwise, feel free to ask in class, and I can try to spend more time on it. Alright, so in other words, we need to multiply this direction times our range to get a line that's this long. So just times max range. There we go. And like I said, so it's kind of, in my mind, a little silly that this works different than that, just a little bit, but that's just how it goes. Just remember that you need, and when you use debug.drawRay, you have to actually multiply times your range. But when you use physics.raycast, it has a separate parameter for the range. Okay, so save this, and basically every frame will be drawing this ray, and it should be red, and it should be exactly the same as this one, except visible. And so let's go to the editor, and if you run it and you look in the game window, you won't see anything. But if you look in the editor window, you will. So make sure you have some sort of split screen, or these two windows need to be out and both visible at the same time. All of a sudden you can kind of see that red line in the right hand view. It's right here, right? That is what my player is looking at. So that's length 5, and it looks kind of long. So let's kind of back up until it's just intersecting the cube, like maybe like there. It's kind of hard to tell. Let's get a side view going. Okay, where's my cube? Wow, yeah. So 5 is pretty far. I don't think I would want to be able to click a button from this far away. That would be like, telekinesis or like some kind of stretch arm ability. Like, I'm thinking more something like this is more appropriate. So let's see what happens if I change max range. Will my debug draw array shrink as well? I'm not sure. Let's find out. I have to go click on this. So let's take it down to like 1. Oh yeah, it did. See? Check it out. So that's 1. If you look at 1, I have to get about like here. That's not horrible, but there's certain things, like what if you have an item on the floor? You would never be able to click it because 1 doesn't even reach all the way down to the floor. So let's crank it up. I don't know, how about like 3? Let's try 3. Mainly, we just want to get kind of close in this eyeball test, and then when we're actually playing, once the functionality is really there, we can see what feels quote-unquote right. Anyway, I don't know, maybe 2.5. Let's try 2.5 for now, and just understand that that's like a pretty fake number. Now remember, when I stop it, since I was running the game changing this, it's just going to go back to what it was at. So make sure you remember what the value was, or just copy it and then paste it. Because when you tweak stuff while the editor's running, it will switch back to its original value as soon as you stop the game. Okay, so there's my my range and my debug draw array. But you know, the next question is, like, we're projecting this imaginary line. Next question is, so what? What good is it for? We need to somehow have this imaginary line tell us what it's hitting. So if you were to go look at the documentation again, you should note that it has a return type. So when you call this function, it's going to give you back data. And the data is of the type bool. So it's true or false. And so the idea is, you can see right here it says returns. True if the ray intersects with something, otherwise false. So more or less, actually let's put this at the top, just that test code there. So basically we can tell whether or not we bumped it, our imaginary ray hit a thing or not. So I'm going to say if, and then get rid of this semicolon, add another closing parentheses. So maybe this is kind of a lengthy condition. So I got another idea. Rather than do that, let's go back to this, and instead we'll say bool, and we'll give it a label like object. I'll say object detected equals that, right? So then we'll know if this will be true or false. Actually, like, how about this? There we go. Object was detected. Alright, and so now we can say if object was detected, and you can just kind of see that this is a little easier to read than this kind of business right there. Alright, so if an object was detected, now what can I do? Well, we need to somehow know about the thing that got bumped by our ray. And there's a sort of a unique trick to that when it comes to raycast, and it has to do with a parameter that we haven't used so far. It's this one right here. It says out hit. Let's see if we can find that version of the method. There it is. So there's all kinds of different versions of this method, remember, and the one that we actually want to use now needs to involve this parameter called hit info, because this way, if our ray actually has bumped something, this hit info parameter will contain more information about what was hit. And you can see it's of the type raycast hit. So it's just like a type Unity made to store information about things raycasts hit. So I need to make a variable for it, right? Because again, we want to make variables for all of the stuff in this complex method we're calling. So this one's of the type raycast hit. So just call raycast hit, and let's just call it hit info, because it's just going to contain information about whatever we hit. And this is a sort of unorthodox way for this to work. Like I said, it's sort of unique to Raycast, but basically there's let's see if we can find the right version of this function. So if I hit backspace on my parenthesis and then re-put it, I get the IntelliSense back, and this way I can kind of keep toggling through until I find the one that's just exactly like we had it, except it also takes this hit info thing. And I think it's this one. And I just needed to do that to figure out where in this list the hit info goes. So it goes right after the direction. So here's our direction, and now in between the direction and the range we need to supply it with this hit info. And the thing about hit info is it needs to be, it's what we call an out variable. So you have to use this out syntax. And you can see here's an example of it here. And what that means is this variable is going to be overridden. It's going to be, whatever its value used to be is going to be replaced when we run this method. Normally that's not how parameters work. Normally they're input parameters. So in other words, we're supplying data into the function so that it can do some computations based on it. In this unique case, we have to provide an output variable where this is essentially blank. We have never initialized it to anything, but when this method is run, it will supply data to this variable. So once we get to this point, if an object was detected, that means that hit info will have some data in it. So if we type hit info here, we can hit period to bring up IntelliSense and kind of see like, oh, what do we know about this stuff? So this hit info is going to contain info about what just got hit, and so we can find the collider of the thing that just got hit. And if we look at the collider, we can find the game object. And if we look inside the game object that's attached to the collider that got hit, we can find its name. So this will tell us the name of the thing that got hit. And by name, I mean like the way it's written in the hierarchy here. So what we can do, you can't just, like, this isn't valid code. This is just not doing anything. We need to, what we could do is say debug.log and then log the name of the thing that got hit, right? So this will print the name of whatever game object was detected by our ray. We can clean this, we can clarify this debug info a little bit. Like, instead of just printing names with no context, we should add a little bit of a label. So we can add a label to the beginning of this. We can say debug, or I'm sorry, we can say player is looking at something like that, and then it will print the name of the thing we're looking at with this additional context. Now, one thing I want to point out while we're doing this is that since we're on Unity 2018.3, it's actually been upgraded to a newer version of C#, which means there's actually a fancy new way to do strings that include variables like this, and it's called string interpolation. And so the syntax for doing that, the idea is that this makes it shorter and easier. So you put a $sign in front of your string, and then you don't need to sort of make separate strings here. You just put curly brackets where you want to plug in a variable, and then close your string. So this is the new way of representing outside data in a string like that with string interpolation. Now, if you want to learn more about this stuff, you can find another link here where it shows, this is actually an article I wrote when I was contracting at Microsoft. Where did it go? Here it is. Where I outlined several of the new features that you can do now that you have the upgraded C# and .NET runtimes in Unity. So there's several other things. So if you're curious, check it out. But I would say more than likely one of the main things that is useful all the time is this string interpolation. So that's pretty cool. Alright. So if we were to save and run this, I think it should start printing the name of whatever we look at. So let's make sure we've saved. Go back to Unity. I'm going to just dock this again so it's easier to see. It's compiling, so it's being slow. There we go. Okay. So run the game, and let's see what happens. So in theory, if I look at a thing, you can see down here in the console, it will tell me when I'm looking at it. So if you look carefully, you can see the number goes up when I'm actually looking at the cube, meaning that's when it's detecting that we're looking at it. You could probably pick up the plane. Player's looking at plane, see that? And I'm not getting this behavior, but if you notice, if you go back to the split screen view actually, you might note that your player, it may be possible for them, like let me click on the player's collider. Oops, sorry. It may be possible to have that red line pierce through your player's body itself, in which case it might start telling you the player is looking at rigid body FPS controller, which would be a bad thing. And if that happened, we'd have to fix that bug by using, there's actually a layer mask parameter we can use to ignore certain objects with our raycast, but since it's not actually happening, I'm not going to worry about it. It actually looks like it's just working fine.
There's just one more thing I wanted to add before we call it a day with this video, and that is some sort of targeting reticle or crosshair so that the player can sort of tell what they're aiming at. Right now, it's kind of, you just kind of have to guess what's the center of the screen. So the simple way we're going to take care of that, at least for the time being, is just by adding a text element, a UI text element to the center of the screen. So I'm going to go right click in the hierarchy window here, and I'm going to choose UI, and I'm going to choose text. And make sure that your canvas is not, a child of anything crazy. It needs to be a top level menu item here. Remember, all of our UI objects are children of a canvas, so they won't show up. You can actually see, if I zoom in really close, my text is right there. And I think that UIs can be confusing at first until you understand that it exists in a separate coordinate space. So if we look at this canvas, you can see that this white outline, I just pressed F. So if you select something and then choose F while you're over the scene window, it will focus on it. Anyway, I click on the canvas and move the mouse back over the scene window, hit F. You can see the big giant rectangle that represents our whole screen. Alright, a couple things I want to set up first. Number one, I want to make sure that I choose my canvas scaler should be scale with screen size, and my reference resolution is going to be 1920 by 1080. And as long as we keep this sort of normal HD aspect ratio, 16:9, things will sort of scale correctly. So it's good to set that up at the very beginning. Alright, so you can see if you click 2D, this gives you a decent example of what the canvas is dealing with here. So I want my text to be in the center of the screen. So I'm going to select the text, and I'm going to change the characters to just be a period, or you could do a plus or any kind of icon that you want to use. If you wanted to use an actual image, you could do that, but I don't want to go through that effort at this moment, so I'm just going to make it a period right now. And I want to make it in the center of the screen, so it says if you hold Alt, you can click here and it will move it to the center. So if you hold Alt, it's not only changing the anchoring, but it's changing its position too. So hold Alt and click the middle one, I'll put it right in the center. Also, I need to make sure that I've centered my paragraph alignment, and I'm going to put it in the middle vertical alignment here as well. And now there's a tiny little period in there, but it's just far too hard to see. Like if you look at the game window, this is what the player would be seeing right now. Can't see anything so much, so let's scale it up. It's important to understand that as you scale, if it gets too big to fit in this text box, it'll stop showing up. So you can kind of see, there's my period. As I scale it up, it eventually disappears. So the way I'm going to fix that, you could just make the text box larger, but I'm just going to choose overflow and overflow, And now I believe I should be able to make it really big so you can see. Now you can actually see it there, right? Now, one thing I want to do is, let's put this, so here's scale 1. This is what it would look like in real life. That's pretty big actually. So maybe take it down a little. You might want to set up your game windows display to add this 1920 by 1080 aspect ratio setting, or you could just go with 16 by 9 and then just take a look at your scale here to make sure like 1x is what will actually look like. Now there's a couple things, like right now this world is very white, saturated with white color, but what if I was looking at something black? I would lose my reticle, right? I'll give you an example. Like, how about I change the reticle from black to white? And so there you see it, but check out when I look at anything white, it becomes hard to see, or almost invisible in that case. So what I'm going to do is add this nifty outline component. This only works on UI text as far as I know, but if I add that component, you can see I've got a white reticle and I'm at a black outline, right, like that. So maybe something about like so, and you can change the size of the outline, and the distance is what the way they're measuring it, just so you can see kind of what it does. That's kind of crazy. So let's give the Y a little more. I don't know, this looks kind of, I don't know if I'm in love with the way this looks right this minute. Let's try resetting it. And it just looks blurry to me. I'm not sure what's going on. Maybe I'll try, let's just choose maximize on play real quick and run it and see what it looks like with a little bit larger of a window here. Oh yeah, it's pretty big. I might actually scale it down a little bit. Let's just scale it down a little bit here. Let's try 38, see what that looks like. Okay. Yeah, that's not so bad, and you can see it's visible whether I'm looking at a white thing, a white material, or the darkest material I have right now, which is still kind of gray, but it's pretty easy to see. Alright, cool. So I have a targeting reticle. Couple little bookkeeping things I want to do. I want to name this, instead of text, I'm going to name it targeting reticle, and I want to save my scene. So we'll say file, save as. I've got a scenes folder here. I'm just going to make a new scene, and I'm going to call it interactive object testing, something like that. It's a good idea to do all your test development in a new scene or a copy of an existing scene, especially if you're working with other developers, just so that you don't have problems merging with them when you go back and commit everything and try to sync up on GitHub. So yeah, so anyway, I should have everything saved now. This is where I would want to commit and push, and I think, we have a pretty demonstrable chunk of functionality done. So yeah, it's a good spot to save your work, commit, and push, because right now our character can tell what it's looking at, and we have a targeting reticle. Alright, so next up we'll start adding in what's missing so that the player can not just understand that it's looking at a thing, but actually interact with the thing. So that'll be next.